Why is data augmentation essential? 4. Setting up computer vision. Imagine trying to teach a robot to recognize different objects in a factory. If it only sees one type of image, it might struggle when things look a little different. That's where data augmentation comes in. It's like giving the robot a variety of pictures so it can recognize items no matter how they appear. In industrial settings, where lighting, angles, and object positions change all the time, this is super important. Data augmentation involves taking existing images and changing them in small ways. For example, you can rotate images by a few degrees, flip them horizontally or vertically, or zoom in and out. You can also adjust brightness, contrast, or color to mimic different lighting conditions. These simple tweaks create new images from the ones you already have. Instead of collecting thousands of new photos, you can generate many variations from just a few dozen images. This saves time and money, especially when capturing images in factories can be costly and slow. One big reason data augmentation is vital is because it helps the computer vision models learn better. Without it, models tend to memorize the training images and perform poorly on new and seen data. This problem is called overfitting. When models overfit, they do well on training images but fail in real-world situations. Augmentation acts like a regularizer, making the model more flexible and able to handle different scenarios. For example, if a factory uses a vision system to spot defects, the system needs to recognize a flaw whether the part is lit brightly or dimly, or if it's turned slightly. Augmentation prepares the model for these variations. In Industry 4.0 and digital transformation, computer vision systems are used for many tasks. They check for defects, sort products, and monitor processes. If the system only trained on one type of image, it might miss issues when conditions change. Augmentation helps the system stay reliable, no matter how the environment varies. For instance, a smart factory might have different lighting setups or parts placed at different angles. Augmentation techniques like rotating images or changing brightness make sure the model can handle all these differences without needing thousands of extra images. Another key benefit is reducing the need for large datasets. Collecting and labeling images in factories can be expensive and slow. By creating many variations from a small set of original images, augmentation boosts the effective size of your dataset. This means faster training times and quicker deployment of AI systems. Studies show that combining different augmentation methods can significantly improve accuracy, sometimes raising it from less than 50% to over 95%. That's a huge boost in performance. In advanced applications like autonomous inspection robots or factory self-driving vehicles, models need to adapt to unpredictable scenarios. Data augmentation helps these models stay accurate even when conditions change unexpectedly. This makes the systems more dependable and ready for real-world challenges. To sum up, data augmentation is a key part of setting up computer vision in industry. It expands your training data without extra data collection, improves accuracy, and helps models generalize better to new situations. It also saves costs and speeds up the process of building reliable AI systems. For any factory or manufacturing operation looking to implement smart, automated solutions, data augmentation is an essential step to ensure success in the digital age.